Hello, today we will be studying about the different types of softening process. One process is zeolite process that we will study. Now these are the contents that we will be covering. What do you mean by softening process? Different types of softener, and today we will study about zeolite softener. Now what is the meaning of softening? Softening is the process by which the hard water is made soft, or we can tell it is the process of removing hardness causing ions. Now what are the hardness causing ions? Calcium ions and the magnesium ions that are here removed. That process is known as softening of water. Now why there is a need to do so? We cannot feed the hard water for our domestic purposes or in the industries. There are really very bad impacts on it. So first it has to be treated and then only we can use it. There are different softening processes. Mainly in your syllabus it is included as zeolite process, deionization process and hot lime soda process. So today we will be studying about zeolite process. The zeolite process is also known as permutive process. It is chemically represented as Na2O, Al2O3, XSiO2, YH2, which is known as hydrated sodium aluminosilicate. The name only suggests how the formula is accumulated. You can easily remember the formula. No need to worry that it is being very lengthy, seems to be very hard. No, it's not like that. Hydrated means H2O, sodium Na2O, aluminum Al2O3 and silicate is SiO2. Now here X and Y are the number of the molecules of the silicon dioxide and water molecules. X ranges from 2 to 10 and Y ranges from 2 to 6. So Na2O, Al2O3, XSiO2 and YH2O, that is your hydrated sodium aluminosilicates, which is nothing but zeolite. This zeolite, sodium zeolite, is commonly represented as Na2Zd. Na2Zd. Now there are two types of zeolite, natural zeolite and synthetic zeolite. Natural zeolite are non-porous in nature. There is no pores at all. For example, natrolite, Na2O, Al2O3, 4SiO2, 2H2O. This natrolite is found in the nature. Synthetic zeolite, these zeolites are prepared in the labs. They are porous, possesses gel structure. They are prepared by heating together china clay, feldspar, soda ash. Such zeolite process has the higher exchange capacity per unit weight than natural zeolite. So these synthetic zeolites are more preferable over natural zeolite. Now coming to the process of zeolite. Now this is the diagram where the zeolite softener works. Okay, it is a cylindrical tapered at the bottom with the inlet entering from the top here. Now the inlet water carries hard water and it connects with the deflector plate. The deflector plate is connected at the top of the zeolite softener. Now what is the function of the deflector plate? Deflector plate distributes the water evenly on the surface of the zeolite bed. If the water enters into the softener and it falls with a force, it will disturb the zeolite bed. Instead of doing so, we cannot afford it. There is a deflector plate attached to that inlet water, which distributes the water evenly by spraying the water. There are small pores. With that help of the pores, the water is being sprayed over the zeolite bed. Now as soon as the water comes into contact with the zeolite bed, various reactions takes place. What are those? Let's study. Na2Ze, that is our zeolite bed, coming into contact with the calcium bicarbonate, NaHCO3 twice. What will happen? It will form CaZe along with the formation of 2NaHCO3, sodium bicarbonate. Now this downward arrow shows that precipitates are formed. So calcium precipitate is formed by this reaction of calcium bicarbonate. That this precipitate will be staying on the topmost layer of the zeolite bed, and the water will carry the sodium bicarbonate ions along with it. Similarly, when the magnesium bicarbonate MgHCO3 twice comes into contact with the zeolite bed, it forms magnesium zeolite PPT. MgZe, the downward arrow shows the PPT formation. That is again retained on the bed of the zeolite bed, and the water carries the sodium bicarbonate along with it. Similarly, when the CaCl2 comes into contact with the zeolite bed, it forms again CaZe PPT, which is retained on the bed, and the water will be having NaCl. CaSO4 when comes into contact with the zeolite, it forms again CaZe PPT, retained on the zeolite bed, and the water will be having Na2SO4. MgCl2 will form magnesium zeolite PPT, that will also retain on the top, and the water will having sodium chloride. MgSO4 is present, that will come into contact with the zeolite to form the magnesium zeolite precipitate, retained on the top, and the water will contain sodium sulfate. So by viewing all the reactions, we are able to know that all the calcium and the magnesium causing hardness are trapped in the form of the calcium zeolite PPT and magnesium zeolite PPT, which are retained on the topmost layer of the zeolite bed. And the water will be carrying all types of sodium ions, whether it is NaCl, NaSCO3 or Na2SO4. Now where does this water goes? This water, after softening, travels through the gravel layer that is placed below the zeolite bed, and then it is collected through the outlet as a softened water. Now this is the whole process where zeolite softening process is done. Okay. Now what happens after 12 to 14 hours when the zeolite bed is fully choked up with the calcium PPTs and magnesium PPTs? No more water comes into contact with the zeolite bed. At that time the softener is known as exhausted. Such type of condition arises here. Now at that time the inlet water stop, supply stop, and the outlet water is put with the tin so that no more precipitates goes into the softening tank. And then it is treated with the NaCl solution that is stored in the storage tank or brine solution. NaCl solution is also known as brine solution. With the help of the injector, it will inject some amount of NaCl solution or brine solution and will put into the zeolite bed for the reaction to take place of the exhausted zeolite to make it again reclaimed zeolite. How it works? Now this is your regeneration process reactions. CaZe, that was the precipitate formed on the zeolite bed, comes into contact with the brine solution NaCl to form Na2Ze, that is your reclaimed zeolite, and the washings will contain CaCl2. Similarly, the MgZe will be combining with the NaCl solution to form the reclaimed zeolite and containing MgCl2 as the washings. Now these washings will be removed to the sink through the another outlet. So all the precipitates will be removed and the zeolite will be again in the working condition for again 12 to 14 hours depending on the intensity of the salts present in that water. So this is how the zeolite softener works. Now coming to the limitations of the zeolite. Each and every process has some limitation. We have to follow that limitations, otherwise more vigorous problems may arise that may cause harm to the softener. Now what are those limitations? If the water supply is turbid, dhundla pani, the suspended matter must be removed first by coagulation, then filtration, before the water is admitted to the zeolite bed. Otherwise, the turbid water will clog the pores of the zeolite bed, making it inactive. So the turbidity has to be removed first, and then only we can feed that water for softening process. This is the first limitation. Second limitation is that water contain large colored ions, manganese ions, iron ions, that has to be first removed, because these ions produce manganese and iron zeolites which cannot be easily regenerated. The permanent exchange occurs which cannot be reclaimed. So the colored ions has to be first removed, and then only we can feed that water to the softener. Now third limitation is mineral acid if present will destroy the zeolite bed, and therefore they must be neutralized with soda before admitting that water to the zeolite softening plant. Now these are the three limitations that we have to take care for nicely conduction of the softening process occurring in the zeolite softener. Now coming to the advantages of the zeolite process. It removes the hardness almost completely, and water produced has only 10 ppm hardness. It is very less and it is affordable for the another industries that can afford it. The equipment used is compact, occupy a small space. No impurities are precipitated, so there is a no danger of sludge formation in treating water at later stage. Now how this topic is related, that will be more clear in the lime soda process. The process automatically adjusts itself for variation in the hardness of incoming water. There is no manual process, it does very automatically. Whether the salts coming that are removed automatically, the whole automatic process is going on. It is quite clean, it requires less time for softening, it requires less skill for maintenance as well as for operation. So these are the advantages of the zeolite process. Now coming to the disadvantages of the zeolite process. The treated water contains more sodium salts than the lime soda process. If we compare the lime soda process, it contains more sodium salts. The method only replaces calcium and magnesium ions by sodium ions, but leaves all the acidic ions like bicarbonate ions, HCO3 minus, and carbonate ions as such in the softened water. It is present as it is. When such softened water containing NaSCO3 or Na2CO3 is used in the boiler for steam generation, NaSCO3 decomposes producing CO2, which causes corrosion, and Na2CO3 hydrolyzes to sodium hydroxide, which causes caustic embrittlement. So the salts, bicarbonate salts and the carbonate salts, acidic ions are also harmful, that has to be removed. This is the major disadvantage of the zeolite process. High turbidity water cannot be treated efficiently by this method because fine impurities get decomposed on the zeolite bed, thereby creating problem for its working. So this is the third disadvantage of the zeolite process. That's all. Hope that you have understood what is zeolite process. If there is any question, you can comment me. I will be giving you answer.